Hey there, Mr. Sutton here with the BC Calculus 517 Part 2 homework solutions on integration by parts. On this problem, we're trying to find the antiderivative of this expression. So I've got an x, I've got a sine of 6x. There's no way to combine these or use any kind of substitution to help me here. So I'm going to have to use integration by parts. So let me write my parts formula out here. And I'm going to have to find uv, du, and dv. For my u value, I have a choice between algebra, the x value there, and trig. I'm going to choose x as my u value, algebra before trig in late. And then my dv is going to be sine of 6x dx. Now picking out my du, that's the derivative of x, which is 1 dx. V, that's the antiderivative of sine of 6x. So let's see here, that's going to be negative 1 over 6 cosine of 6x. Putting it all together, follow the 7. We've got negative x over 6, or negative 1/6 x times cosine of 6x. And then we have the minus the integral of, well, actually we're going to be plus because there's a minus already built in there. So plus the integral of 1/6 cosine 6x dx. And then taking the antiderivative here, so I've got my original expression here, plus, this is going to be, let's see, we have 1 over 6 sine of 6x, but now we have to divide by 6. So that's 1 over 36 sine of 6x plus c. And that's going to be answer choice. Let's see, we have a negative 1 over 6 cosine, or negative x over 6 cosine, and then we also have to add 1 over 36, so that's choice B. They all look so similar. For this problem, we want the antiderivative of x times e to the 2x. Since I can't use substitution or simplifying at all on this one, I'm going to use integration by parts. So here's my formula, uv minus integral of v du. Picking my u value, that's the one that's easier to take the derivative than it is to integrate. Using the LATE acronym, I have an A for algebra versus an E for exponential. So I'm going to use the algebra one for u. That's x equals u. And then my dv, I'm going to choose e to the 2x dx because it's the only one left. Now taking the derivative of u, du is going to be 1 dx. Antiderivative of dv to get the v value, well, that's going to be e to the 2x divided by 2, so 1/2 e to the 2x. Time to plug stuff in my formula. So doing my 7 here, I've got x times 1/2 e to the 2x, so 1/2 x e to the 2x. And then I'm going to be subtracting the integral of going this way now. This is going to be 1/2 e to the 2x dx. And at this point, let me write out my first thing again. And now I have to take my integral. And I just simplified my first thing a little bit to look more like the answer choices with a true fraction instead of like a 1/2 out in front. So now taking this antiderivative, I've got e to the 2x, and I have to divide by 2. So this is going to be 1/4 e to the 2x. Or you could say e to the 2x over 4 plus c. And that's going to give us which answer choice? Well, that looks like answer choice A. For this problem, we're trying to find the antiderivative of x times f of x dx. And the only information we're given is that f prime equals negative f. All right, well, let's try and find this antiderivative then, and hopefully we can match it with one of these. So because I have x and f of x, and f of x isn't really much of anything, they didn't tell us, I'm going to have to use integration by parts. I can't really use substitution or simplifying if I don't know what f of x really does. So here's my parts formula, uv minus integral of v du. And for my u value, I'm going to have to pick something that's easy to differentiate. And this is a tough choice because x and f of x are both pretty easy. I mean, the derivative of x is 1. The derivative of f of x is given right here to us. So that's hard to make a choice between those. So let's think about what we want our dv value to be, and then we'll just let u be the thing that we don't pick. For dv, I want something that's easy to integrate. So I have a choice between x and f of x. Which one would I rather have to integrate? Well, if I integrate f of x, we might be able to use this statement here with f prime and f being related. If I integrate x, that's going to make it something with an x squared, which is going to make it more complicated, not less complicated. So I don't really want to integrate x. For that reason, I'm going to let u be x and dv be f of x dx. I would rather integrate f of x than I would u. So taking our derivative of u, which is the whole easiest part of this whole problem, we have du equals 1 dx. Antiderivative now of f of x, because I want to get my v value up here. Well, we're told that if I take the derivative of positive f, I get negative f. So if I want to get positive f as a result, that means I need the derivative of negative f. All right, so let's go ahead now and plug this in our formula. We've got the uv here. That's going to be negative x f of x. Following the 7 here, I also need my integral. So I'm going to be doing minus negative f of x times 1 dx. And you might be wondering, well, why didn't I just simplify this right away as plus integral of f of x? I have my reasons, which I will show you now, because we need to take the antiderivative of negative f of x. So you might be saying, well, isn't the antiderivative of negative f of x just f? And actually it is. If f prime equals negative f of x, taking the antiderivative of both sides, that means f equals the antiderivative of negative f of x dx. This expression right here is just f. So I've got negative x times f of x minus f of x, and then don't forget your plus c, and then, oops, none of the answer choices, so we got to go a little further. Now, some of these answer choices, it looks like they factored out an f of x or a negative f of x. So let's see if that would work for us here. These both have an f of x in them, and they're both negative, so I'm going to try factoring a negative f of x out of this expression, at least the first two terms. That's going to leave me with positive x minus 1, and then I still have that plus c. So that ends up matching answer choice B. On this problem, I've got a table of values for f, g, and their derivatives. I'm told that the integral from 0 to 1 of f prime g is 5. I want the integral from 0 to 1 of f times g prime. So because I don't really know what f and g are doing and can't simplify or substitute in any way, I need integration by parts here. So here's my definite integral integration by parts formula. And now I'm going to need to find u and v and dv and du. So let's start with the u value. That's the thing that would be easier to take the derivative of. I have a choice between f and g prime. Well, between the two of them, I would rather take the derivative of f because I have some values for f prime in my table. I don't have anything for g double prime, so I'm going to do u equals f of x. And then dv, I'm going to have, that's going to have to be g prime of x dx. All right, du then is going to be f prime of x dx. V, the antiderivative of g prime, that's going to be g, and I'm actually okay with that because we have some g values in that table. Moving on then, let's go ahead and plug things in our formula. So for uv, I've got f of x times g of x evaluated from 0 to 1. Those were our limits of integration, minus the integral of f prime of x times g of x dx. That's the v du part. And now at this point, normally I would take the antiderivative of this stuff over here, but if you look down here, they actually gave it to you. They said that that antiderivative or that definite integral had a value of 5. So I'm just going to start in evaluating this box here, and I'm going to subtract 5 when all is said and done. So I've got both of these things with 1 plugged in, minus both of these things with 0 plugged in, and then minus, we said this had a value of 5 that they gave us in the problem. So f of 1, what's that? Well, that's 4. G of 1 is 3, so 4 times 3, minus, and then we're doing f of 0 times g of 0, so 2 times negative 4, still subtracting 5. Now it's just arithmetic. We've got 12 plus 8, which is 20, minus 5, which is 15. Choice E. On this problem, we want the definite integral from 0 to pi over 2 of x cosine of x. Since I can't substitute or simplify this expression, I need integration by parts. Let me write out my definite integral version of that formula here. And now finding u and v values, I have a choice between algebra and trig, so I'm definitely going to go with algebra for my u value because I would rather differentiate that than anti-differentiate it. And then dv is going to have to be cosine of x dx. So that means du is 1 dx, and v, the antiderivative of cosine of x, that's going to be sine of x. Plugging it all in now, we have x times sine of x, evaluated from 0 to 2, or pi over 2, minus integral from 0 to pi over 2 of, now we're going this way, so that's just sine of x inside that integral. All right, so I've got, I'm going to open up my evaluation box and include the stuff from this integral I'm about to take the antiderivative of. So I've got this original x sine of x that's still in my box there. And over here, antiderivative of sine is negative cosine, but we've already got a negative out in front. So this is going to be a positive cosine that I'm putting in there and evaluating now from 0 to pi over 2. So we've got all of this stuff with pi over 2 plugged in, and all of this stuff with 0 plugged in. So let's see now. Sine of pi over 2, that's 1. 1 times pi over 2 is just pi over 2. Cosine of pi over 2 is 0, so we don't have to worry about that. Over here, I've got 0 times whatever is going to be 0. And we also have cosine of 0, which is positive 1, but that's being subtracted. So when the dust settles, I have pi over 2 minus 1, which is answer choice E. For this problem, I'm trying to find the antiderivative of x times cosine of 2x. Since I can't use substitution or any kind of simplifying on this really, I need integration by parts. So that's uv minus integral of v du. For my u value, I'm choosing between algebraic, that's this x here, and trig, the cosine. I'm going to choose x for u because I always choose algebraic before trig, a before t in that acronym late. That means dv has to be cosine of 2x dx. For my derivative, my du, that's going to be 1 dx. And then v, the antiderivative of cosine 2x, that's going to be 1/2 sine of 2x. All right, multiplying things out and getting my formula plugged in here, we've got 1/2 x times sine of 2x minus the integral of 1/2 sine of 2x. And now going left to right here, this stuff isn't changing at all, but the integral, now I have to take my antiderivative. Antiderivative of sine is negative cosine, and I have to divide by 2 because of the 2x in here. So this is going to be negative negative or positive 1/4 cosine of 2x plus c. So that's going to be, let's see, answer choice D. For this problem, we're given that antiderivative of f of x sine of x equals all this craziness, and we want to know what this random f of x function that I see twice is. Okay, so this is an integration by parts kind of situation. There's no other situation where you have something that's not an integral plus something that isn't an integral, and they're both functions. So I'm going to write my integration by parts formula, and basically using the form of this formula, I'm going to try to figure out what's what in terms of these different letters. So the easiest thing to pick out is the v value, because that's repeated in your IBP formula. Looking up here, the only thing that's repeated is this cosine of x, so that seems like a pretty good candidate for v. But we have to be careful. Is it negative or positive cosine? It can be kind of hard to tell sometimes. I notice over here that we have a negative in front of the f of x. So does that negative belong with f of x or cosine of x? Well, I think if the function f were negative, it would be included in the actual function itself. They wouldn't need to put a negative outside over here. So this suggests that cosine is negative. And if you look in here, well, this used to be a minus integral, and now it's positive. So again, I think that negative from the cosine is what's making that positive. So I'm going to put negative cosine is our repeated term, which is to say I'm assigning a v value here of negative cosine of x. That means that dv, that's the derivative of this, that's going to be sine of x dx. Now, that matches what's in the original formula, so far things are matching up. Moving further, I need to find du if I'm going to work backwards and find u. Du is the thing that's tagging along with v inside this integral. Looking up here, I've got this 3x squared. Since cosine is already negative, and it's taking care of that negative in front of the integral, that means this must be a positive 3x squared for my du value. And then if I want u, I need to take the antiderivative of this. That bumps up to a 3. Dividing, we have x cubed. So x cubed, since that's u, that means that it's the f of x in that original integral expression. So that means we need answer choice B. For this problem, I'm given a table of f and its derivatives, first two anyway. I want the value of integral from 0 to 1 of x times f double prime of x dx. Since I don't know what the f function actually does, I can't simplify or substitute, so it's integration by parts or nothing in this one. So there's my IBP definite integral formula. For my u value on this one, I'm going to pick the thing that is easier to differentiate than to integrate. Between x and f double prime, I would rather differentiate x and integrate f double prime. So I'm going to let my u value then be x, and dv is going to be f double prime dx. Now I can take the derivative of u, or x, which is 1 dx. Antiderivative of v, or of dv rather, is going to give me v. That's just going to be f prime of x dx. Putting it all together now, following the 7, for this uv in here, I've got x times f prime of x from 0 to 1. For my integral inside there, I've got just f prime of x dx. So I've got this original x times f prime of x from 0 to 1. And I'm going to throw another thing inside that evaluation box, since the limits of integration are the same. Antiderivative of f prime is just going to be f, so I'm subtracting f of x from 0 to 1. And now it's time to evaluate and get one of these answer choices. So if I plug in 1 to all of that stuff, and then subtract whatever I get when I plug in 0 to all that stuff, let's see what it comes out to. This 1 in front makes no difference. F prime of 1, I can look that up in the table. That's 6. Minus f of 1, so minus 2. That's f of 1 in the table. And over here, I've got 0 times f prime. Doesn't really matter what f prime of 0 is. 0 times that's going to give us 0. So then it's just this f of 0. F of 0 is 1. We're subtracting it inside and outside, so we're actually adding 1 then. So 6 minus 2 plus 1 gives us 5. Choice B.